All right, let's continue our work on vertex edge graphs. This is a second video. This HW means that this is the day 9 homework. The day 9 classwork, CW, is actually the first video in this series. So if you did not watch day 9 CW, you should go watch that first. Anyway, determine the number of vertices and edges in the vertex edge graph. Well, the vertices are just these corners, and the edges are the connections between them. So this has 3 vertices, and it has 3 edges. This one has 4 vertices and 3 edges. This one has 4 vertices and, let's see, you got to be careful, 1, 2, 3, 4 edges. Alright, notice we do not count these segments as separate edges. The only thing that counts as an edge is something that is connecting one vertex to another vertex. So vertex to vertex, that's an edge. Alright, vertex to vertex, that's another edge. Okay, and then there's an edge, and here's an edge. Okay, those are the 4 edges. Okay, moving on. Here we have 1, 2, 3, 4, 5 edges, 5 vertices. And we have 1, 2, 3, 4 edges. Here we have 1, 2, 3, 4, 5, 6 vertices. And we have 1, 2, 3, 4, 5, 6, 7 edges. Okay, let's see. We have 1, 2, 3, 4, 5, 6 vertices on number 6. And we have 1, 2, 3, 4 edges. Alright, so just getting comfortable with that vocabulary. Determine whether the statement is true or false. I'm going to switch back to RAID. The vertex edge graph at the right represents 5 people at a party. 1, 2, 3, 4, 5. Okay. Angela, Bruce, Callie, Dave, and Eve. An edge connecting the 2 vertices indicates that those 2 people had a conversation during the party. So, true or false? Angela had a conversation with everyone. Let's see, Angela had a conversation with Bruce and Callie and Dave and Eve. There's a connection to everyone, so that indicates a conversation with everyone. So that one is true. Bruce had a conversation with 3 different people. Let's see, what do you think about that? It seems false. Bruce had a conversation with Angela, and Bruce had a conversation with Callie, and that's it. So only 2 different people, so that is false. Eve had a conversation with 2 different people. Alright, Eve had a conversation with Dave and Angela. So that is true. 2 different people. Okay. Callie had a conversation with Dave. Nope, Callie did not have a conversation with Dave. If she did, there would be a connection right there. So that is false. Okay, so I think that's it for that. So that's just getting you comfortable with the meaning of vertices and their connections in a real world problem like this. Okay, let's see what's next. Okay, in exercises 11 and 12, each vertex of the vertex edge graph represents a rest stop in a forest. An edge connecting the two vertices indicates that the rest stops are connected by a hiking trail. Write a matrix that represents the vertex edge graph. Okay, this was covered in day 9 classwork video, but we'll do it again. Look at how many vertices there are. There are 4 vertices. So we are going to have to construct a 4x4 matrix to show you how it's done. I'm just going to slightly cheat and use a table to help me keep my numbers straight, but you don't need a grid. Okay, you can just keep your numbers as neatly as you can in rows and columns. But since I'm teaching it, I figured I better keep it straight as possible for you guys. So look, I've got A, B, C, D. So I'm going to put that down the rows, A, B, C, D, and I'm going to put that across the columns, A, B, C, D. So remember, each one of these represents a rest stop, and the connections represent a walking path, a trail between the rest stops. So you cannot have a trail leading to yourself. Okay, so A to A would represent a trail from point A to point A. That can happen. B to B, that can't be. C to C, D to D, you can't have a trail from a rest stop to itself. So those are all zeros, 0 trails. Now, is there a trail between rest stop A and rest stop B? Yes, it's right there. There's one trail from A to B. Every time I put down an entry, it's going to be duplicated somewhere else on the matrix because A to B is the same thing as B to A. Okay, so there's one trail from B to A as well, same thing. Now, is there a trail between A and C? No trail between A and C, so I put a 0. So that means there's also no trail between C and A. Duplicate it. Is there a trail between A and D? Yes, it's right there. It's one trail. That means there's a trail between D and A, so duplicate it. What about between B and C? Yeah, there's a trail. There's one trail. That means C and B, there's a trail as well. What about B and D? Yes, there is a trail between B and D. That means between D and B, there's the same trail. What about between C and D? Yeah, there's a trail between C and D, which means there's also a trail between D and C. Okay, go ahead and put a bracket around your matrix, all right, to show that it is a matrix like this. Okay, so there's a matrix. Now I'm going to see if I can delete this grid to make it more legit. All right, so there you go. So that's how yours is going to look. Now, if you were just copying off of me just then, which you really should never be just copying your homework off the video, but if you were, at least pause the video now and try to do number 12 on your own. All right? Try to do number 12 without me and just check your answer. Do not just copy another problem off of me. All right, so we're just going to do the same exact thing with number 12. Okay, and it's even the same letter. So we got A, B, C, D, and A, B, C, D. So A to A, B to B, C to C, D to D. All right, you cannot connect a rest stop with itself. It's just a single point. What about between A and B? Is there a connection? Yes. That means between B and A there's a connection. What about A and C? Yes. That means C and A, yes. What about A and D? Yes. That means D and A. What about B and C? Yes. That means, wait, what did I say? B and C. That means C and B. What about B and D? Oh, that's where the fail starts to happen. There's no connection between B and D. So that's going to be a 0, 0 connections. That means between D and B there are 0 connections. And what about between C and D? No, no connections between C and D. That means between D and C there are no connections. Okay, so this is what we've got going on here. Wait, I messed something up. Okay, going back. I was going so fast that when I talked about the connections between A and D, I saw there was a connection and I just put a 1. But that is actually only half true, because between A and D, not only is there a connection, but there are actually 2 connections. Okay, we have this one that looks straight here, but then we also have the connection that goes like this. So there are 2 paths between A and D. So on the A and D connection spot, we should put a 2 to reflect that there are 2 paths between A and D. Okay, I almost neglected that. That was very important. So this is the matrix that we're dealing with. Go ahead and put a bracket around it to show that it is in fact a matrix. Alright, so number 12 should look like that. Alright, what else you got? Bring it. Number 13, transportation. An airline serves 4 cities. Okay, Asheville, Bedford, Grantsville, and Hanover. Okay, so I guess we'll use A, B, G, and H. There are flights between Asheville and Granville. Okay, draw a vertex graph to represent the situation. Okay, let's draw the vertex graph as I read along. So we need some vertices. So A, B, G, and H. So here we go. There's A, B, G, and H. Okay, those are the vertices. So there we will use a connection to represent any flights between 2 cities. So there are flights between Asheville and Grantville. Okay, so Asheville and Grantville, Asheville and Hanover, Bedford and Grantville, and Bedford and Hanover. Okay. Draw a vertex edge graph to represent this situation. Bam! I just did that. Okay. You're amazed. I know you're amazed. Now, use matrix A to represent the vertex edge graph from part A. So we're supposed to take this and do the matrix like we've done before. Okay, so once again, I need a 4x4 grid. Okay, so we've got A, B, G, H, A, B, G, H. Once again, you cannot have a flight from a city to itself. So all of these along the diagonal will be zeros. Is there a flight between A and B? No flights there. That means BA, no flights. What about A and G? Yeah, there's a flight. Boom. What about A? Oh, wait. So A and G, so therefore G and A. What about A and H? Yup. That means HA as well. What about BG? BG, there's a flight. That means GB, there's a flight. What about BH? BH, there's a flight. That means HB, there's a flight. What about GH? No flight between G and H. So that means no flight between H and G either. Okay, so put a little bracket around this, and you've got yourself a matrix representing the situation. Okay, so there you have a nice matrix representing the situation. Okay, now for part C, we are supposed to use this matrix to have some other information. So use the matrix you found in part B to calculate A squared. Okay, they're not saying what this means, but I want you to understand that when we calculate A squared, the matrix that we get is going to show us between any two cities how many flights there are, how many ways there are to get from one city to another using exactly 2 flights. Okay, the 2 means 2 flights, 2 connections. All right, in terms of this, it means if I wanted to get from A to G, but I wanted to take 2 flights to do it. So instead of going from A directly to G, I'd have to go somewhere else and then to G. So if I wanted to get to B in 2 flights, I'd go to H and then B. Okay, or I could go to G and then B. That would be 1, 2 flights, 1, 2 flights. So when you square a matrix, it tells you how many ways there are to get where you're going in 2 flights or whatever. If it's cubed, that would be 3 flights. If it's to the 4th power, that would be 4 flights, etc. Okay, so let's go ahead and do it. To do this, you need a graphing calculator. So if you don't have a graphing calculator, then you're just going to copy this part off of the video. Okay, here I have my TI-84 Plus graphing calculator. Okay, I'm just gonna start. Let me get out of this. Oh yeah, that's what it is. Clear. So let's just start from a clear screen. In fact, well, never mind. Let's just start from a clear screen. All the matrix stuff is under this menu. So you see that it's kind of above the X inverse button. It says matrix. So that means I hit second matrix to get in there. Okay, now we need to edit ourselves a matrix, so we need to get over to the edit menu. I'm going to hit the left arrow key to get there. Alright, I'm going to put this information in matrix B. So I'm just going to go down and hit enter, or I could have just typed the number 2. So now I'm in matrix B. This is a 4x4 matrix, so I'm just going to type 4, enter, 4, enter, to turn this into a 4x4 matrix. Now I'm just going to type in all these values one at a time. Every time I type a number, I'm going to hit enter. So I'm going to hit 0, 0, 1, 1. 0, enter, 0, enter, 1, enter, 1, enter. And it automatically wraps around to the next row. So 0, 0, 1, 1. 0, enter, 0, enter, 1, enter, 1, enter. 1, 1, 0, 0. 1, enter, 1, enter, 0, enter, 0, enter. Same thing one more time. 1, 1, 0, 0. 1, enter, 1, enter, 0, enter, 0, enter. Alright, once you enter the last value, you're always going to have to quit to get out of a matrix. So hit second mode in order to quit your way out. Now, we need to get back into the matrix area, though, to do what they asked us to do. So hit second matrix again, and notice there's our 4x4 matrix B right there. And this time, we just want to print the matrix on the screen. So let's just go down to B, or I could have just hit the number 2 and hit enter. So that just prints the B. Now remember that we're supposed to be calculating A squared. Okay, well, I hope it's not confusing because I put it in B, so for us it'll be B squared. Okay, why didn't I use A? In case you're wondering, I'm using for a different problem, and I didn't want to type it all over again. So to do B squared, I could just hit the little square button like that. Now, if I needed something, a higher exponent than 2, okay, then I could have hit the caret button. And hold on. Okay, say if I wanted b to the third power, I could hit the caret button and hit 3, and then it would be b to the third power. Okay, but I want b squared, so there it is. So I'll just hit enter, and so this would be b squared. Notice it is not what you would get if you just squared all of these individual pieces. It's doing a whole row times column and adding them up thing. It's doing matrix multiplication as it should. So this is the matrix that you would get, and you would just copy this matrix down for C. And there you go. We should still have our little labels on here with our A, B, G, H, A, B, G, H. Okay, so there's A squared. And again, notice this means that if I wanted to get from city A to city B using 2 flights, there are 2 ways for me to get from A to B. Notice that these are not zeros anymore along the diagonal, because if I want to get from city A to city A using 2 flights, I can do that. Okay? I can go from city A, I could go from A to G and then G back to A. That's 2 flights. Or I could go from A to H and then H to A again, and that's 2 flights. So that's why there are 2 ways to get from A to itself. Okay? Alright, so that's the meaning of it, and that's how you do it, and I'm late for lunch due date. So that is luckily the end of this video.